Have you ever really stopped to think about what's going on inside the machine you use every single day? Well, today we're going to do just that. We're cracking open the case and doing a full digital dissection of a modern computer. We're going to take it apart, piece by piece, so we can really understand how all this incredibly complex hardware manages to work together. You can think of this kind of like a biology dissection, but, for technology. We're going to start with the big components, the stuff you might even recognize, but then we're going to journey all the way down, way down, to the nanoscopic, silicon-based world where the real magic happens. I mean, look at this. When you lay out all the parts of a computer, it's just a lot. And the source material nailed it with this quote. It really does look like a bit of a crime scene. It might seem like total chaos, but trust me, there's an incredible, beautiful order to all of this. So let's start making sense of this crime scene, and we'll begin with the brains of the whole operation. All right, first things first. We're starting with the most critical parts, the components that do all the heavy lifting, all the thinking. We're talking, of course, about the CPU and the GPU. So let's meet the most famous brain of them all, the central processing unit, or CPU. This is the primary workhorse of your entire computer. It's like the master conductor of an orchestra, just executing millions and millions of instructions every second to make all your software actually run. Now, from the outside, a CPU just looks like a simple little metal square, right? But it's actually a multi-layered sandwich of technology. If we were to peel it back, the first thing we'd find is the integrated heat spreader. That's basically its protective metal hat. But under that is where the real magic is, the silicon chip itself, which is technically called a die. And that tiny die is mounted on a small printed circuit board, which acts as the base that lets it plug into the rest of the computer. And this is where the scale just becomes almost impossible to wrap your head around. On that tiny little piece of silicon, that die, which is often smaller than a postage stamp, manufacturers cram somewhere between 8 and 10 billion microscopic switches. They're called transistors, and they form what the source material calls a multi-layer labyrinth, a circuit so unbelievably dense it can perform billions of calculations every single second. It's just wild. But wait, in most modern computers, the CPU isn't the only brain doing the work. We also have the graphics processing unit, or GPU. This is another beast of a processor, and it usually lives on its own dedicated card. It was designed specifically to handle the absolutely immense task of creating everything you see on your screen. So why have two brains? Well, it's all about how they're built. Their architecture is totally different. Think of the CPU as a small team of brilliant specialists. It's got a few super powerful cores that are designed to tackle really complex problems one after another. The GPU, on the other hand, is like a massive army. It has thousands of simpler cores that all work at the same time. This makes it absolutely perfect for tasks that can be broken down into tons of little parallel jobs, like, say, rendering millions of pixels for a video game all at once. Okay, so we've got these two powerful brains, but how do they talk to each other? And not just each other, but every other part of the computer. Well, that brings us to the data superhighway that connects this whole system. And the absolute heart of the superhighway is the motherboard. This thing is a massive printed circuit board, and it's basically the computer's central nervous system. Every single component, from the CPU to your mouse and keyboard, plugs right into the motherboard. It's what allows them all to communicate and work together as one. Now, a really key part of that hub is something called the chipset. You can think of the chipset as the motherboard's dedicated traffic controller. While the CPU is busy with high-speed stuff like talking to memory in the GPU, the chipset is managing the data flow for pretty much everything else. We're talking USB ports, your Wi-Fi, your hard drives, your audio. It's the component that keeps all that data moving where it needs to go nice and smoothly. So, let's talk about where all that data actually lives. A computer doesn't just jam everything into one big box. Nope. It uses a really clever hierarchy of memory and storage to make sure everything runs as efficiently as possible. And that hierarchy usually has three main levels. At the very top, the fastest of the fast, you have DRAM. That's your system RAM. It's incredibly fast. We're talking access speeds in nanoseconds. But it's temporary. It's just for holding the programs you're actively using. Then, for long-term storage, you've got solid-state drives, or SSDs. They're still very fast, accessing data in microseconds. And finally, at the bottom, you have the old-school hard disk drives, or HDDs. They're the slowest, taking milliseconds, but they give you huge amounts of cheap storage. You need all three tiers to get that perfect balance of speed and capacity. Okay, so all of these high-speed parts are incredible, but they're also totally useless without two critical things: a constant, steady supply of power and a way to get rid of all the heat they generate. This is the computer's life support system. First up is the Power Supply Unit, or PSU, and this thing is truly the unsung hero of the entire build. It takes the dangerous, high-voltage electricity coming from your wall outlet and carefully converts it down into the stable, lower voltages that every single component inside your computer needs to operate safely. Without it, everything would just fry. Now, a natural side effect of using all that power is heat, an enormous amount of heat. To give you some perspective, a powerful CPU running at full tilt can generate as much heat as 16 LED light bulbs, all burning at once in a tiny space. Without a serious cooling system, that chip would literally melt itself in seconds. So how in the world do you manage that kind of inferno? Well, a modern liquid cooler is a pretty cool piece of engineering. It starts with a small pump that circulates a special coolant. That liquid flows over the hot CPU, absorbing all its heat. Then, the now hot liquid travels through tubes to a radiator, where fans blow air across a bunch of fins, pushing the heat out of the computer case. And then, the cooled liquid cycles right back to the CPU to do it all over again. And this brings us right back to the central idea of this whole dissection. The source material puts it perfectly. Alone, each of these components doesn't do much at all, but when united, they combine to form a powerful system. That's the real takeaway here. It's this incredible, seamless integration of all these specialized parts working together that creates the magic we get to use every single day. So we've journeyed from the outside of the case all the way down to the billions of transistors that are the very foundation of our digital world. And it leaves us with one last, really fascinating question to think about. If this is the complex anatomy of today's computer, what on earth will the digital organisms of tomorrow even look like?